active compound means the compound which has chiral center or asymmetric center is called as a optically active compound. Okay, and the compounds which are exhibit as enantiomers. Okay, the compounds which are exhibit as enantiomers, that compounds also we can call as a optically active compounds. What is meant with the enantiomers, which we can call as enantiomers? So enantiomers are nothing but non-superimposable mirror images are called as enantiomers. What is meant the enantiomers here? Enantiomers are called as here non-superimposable mirror images are called as enantiomers. And what is meant with the diastereomers? Diastereomers is nothing but superimposable mirror images are called as diastereomers. Okay, so what is meant the diastereomers means here? Diastereomers is nothing but superimposable mirror images are called as diastereomers. Okay, so sometimes in examination they're asking the questions. Okay, so find the chiral carbon. Okay, so chiral and opposite word is achiral. Okay, so chiral means what is meant by the chiral? Samhita, what is meant by the chiral? So yesterday we had seen na. What is meant by the chiral? What is meant by the chiral?
Asymmetric carbon, sir,
Which is it's chiral carbon also we can call as asymmetric. Asymmetric is nothing but the carbon which is attaches
attached
with the
different group.
four different atoms or group of atoms is called as a chiral. Okay, so then what about the achiral? Achiral. So achiral means the carbon which has a symmetry. That means here the carbon which is attaches with the identical atoms is called as a achiral. Okay, so what is the achiral? Achiral means here the carbon which is attaches with identical atoms with identical atoms or group of atoms or group of atoms is called as here atoms is called achiral, is called achiral. Okay, at the same time the compound which has a symmetry, that is also we can call as a achiral. Okay, the compound which has here so symmetry, either it may be plane of symmetry, center of symmetry or axis of symmetry means here, that is also we can consider as a achiral. So what is the example we can write for the achiral means here? We can write as, for example, general example I'm writing C bond, A bond, bond B and C it is there. So if the given compound is either it is a chiral or achiral means this we can call as a achiral. Sir, how you are telling that this achiral means here? For example, here if you see means in the structure, the carbon is attaches with the two identical atoms. So generally chiral means four different atoms or group of atoms it has to be there. Then only we can call as a chiral. But this one is attaches with identical atom. Okay, in mains level or something here. So how they're asking the question mean based on the number of chiral center they're asking. Otherwise, they'll give some condensation formula. Okay, they'll give some condensation formula and they're asking to find out whether the given compound is chiral or achiral. So that kind of questions also they're asking. For example, as per the examination pattern, let us see if I had given like this. If I had given like this, what is the example means here? Here, CH3, CH, OH, COOH it is there. Actually, given molecular formula is condensation we can call. It is a condensation formula. What is the IUPAC name of this one? Any one of you? What is the IUPAC name of the given compound? Samhita, Sai Akshit, Anjan, any one of you. What is the IUPAC name of the given compound? So what is the IUPAC name of this one means here? We can write as a 2-hydroxy propanoic acid. Propanoic acid. 2-hydroxy propanoic acid. Okay, so 2-hydroxy propanoic acid is the optically active compound or optically inactive compound? That is my question. 2-hydroxy propanoic acid is optically active or optically inactive? Anjan or Samita or Sayachi. What is the answer? Is the given compound is optically active or optically inactive? Anjan, you are giving some answer.
Is it inactive, sir?
That no. Are you telling that it is inactive?
Like
Sir,
having
Anjan, I'll give the clarity. So whenever they had given this kind of structure means, immediately you have to write as a complete representation. Okay, so complete representation means here, so carbon, first how many carbon atoms are there? 3 carbon atoms are there. First I'm writing as a 3 carbon atoms in a straight manner. And terminal one is already COOH, it is there. COOH. Okay, so that is also if you write complete representation means this is also we can write in the form of C double bond O bond OH. So each carbon is having the tetravalence. Now this carbon is having 4 bonds. Now the tetravalence is satisfied. And the second carbon atom, if you observe the second carbon means this carbon is attaches with the hydrogen and OH. Already it is attaches with the 2 neighboring carbon atoms. If it is attaches with the 2 neighboring carbon atoms means OH and H it is there. Okay. Now last carbon atom. So last carbon atom if you check it out means here H, here also 1 H it is there, here also 1 H it is there. So what I am telling that which compounds are optically active means here the compounds which are having chiral center is called as optically active. Now we can find out the chiral center. Either the given compound is having the chiral center or not. First we can check it out. So if you see first carbon atom is attaches with the 2 oxygen atoms. That means 2 are identical. That means first carbon is it acts as a chiral because of identical atoms. And second carbon if you see means, so it is a group of atoms, COOH we can consider it as a group of atoms. And last one we can check it out, CH3, this carbon is attaches with the 3 identical atoms. If the carbon is attaches with the 3 identical atoms with that we can call as a achiral. Okay, and second carbon atom once you check it out, second carbon atom, this one we can consider it as a methyl group, and this one we can consider, clearly I'll write my here. So this also we can write COOH bond OH H and CH3 it is there. So this is the structure. Okay, this also we can write like this. Now second carbon atom you can check it out. The second carbon atom is attaches with 4 different atoms or group of atoms. If it is attaches with the 4 different atoms or group of atoms means then the given carbon is called as a chiral or achiral. Samita, the given chiral. If it is chiral means either it is optically active or optically inactive ma.
Optically active.
Very good. So this one is optically active. Optically active.
Sir,
So
how did
Anjan,
you draw the structure for this?
ma,
Sir, how did you get that structure?
how did you get the structure means because of starting GOC representation of the organic compounds we have one concept. I don't know whether you read or not. So that's why starting only I asked. Let's see organic GOC is very very important. Okay, all basics are there in this chapter. Representation of the organic compounds. Organic compounds can be represented with the condensation form, complete representation form, okay, and line representation, 3D representation, solid weights, and dash representation. One it is there. All these are the different representation. And And that is also carbon is having the tetravalency. Whenever you are writing the structure means here, we have to check it out. Either it is having carbon is satisfied with the tetravalency or not. That we have to check it out. Okay, according to that one, I wrote one. Nothing else. I didn't do anything. I didn't do anything. So just according to the tetravalency, I wrote the structures. Because I have some basics. That's why I'm able to write. Okay. Can I give one more structure? Can I give one more condensation form?
Yes, sir.
Okay. So now I'm going to give one more condensation. So one more example. So yesterday I forwarded some assignment. So in that one, they are asking like these questions here. That means in mains exams also they're asking the questions here. Either the given molecule, they give some structure and they're asking either the given compound is exhibit as optical isomerism or not. Simply condensation formula. And some places what they had given, so that they had given name only. They had given name. Okay. So if, for example, I'll give one more structure here. Now my question is 2-chloro 2-chlorobutane. Is 2-chlorobutane is optically active or optically inactive? Any one of you? Is 2-chlorobutane is optically active or optically inactive? And I'll give one more also. Here,
Optically inactive.
optically
Inactive.
Aditi. So you're telling that optically inactive. Is it right?
Yes, sir.
Okay, optically inactive. And 2-chloropropane, same question. 2-chloropropane. Is 2-chloropropane is optically active or optically inactive? Come on, Anjan, Samhita, Aditi, Sai Akshit.
Sir, it's inactive because it has two methyl groups like CH3 on
So,
both the sides.
right, you are telling that 2-chloropropane is optically inactive. Is it right?
Yeah, sir, because it has two methyl groups on either side.
Exactly, Aditi. Whatever you said, it is correct only. But why you can't check it out 2-chlorobutane? Once you check it out the structure, so whatever you told, it is exactly correct. But whatever the first answer, it is wrong answer. It is optically inactive.
I took one of the group as CH3 instead of CH2.
Optically inactive. Sir, if anyone you are having doubt means once you check it out, I'm going to draw the structure of the 2-chloropropane. So
So first one is active, optically active.
very good, Aditi. First one is optically active. Sir, first one the carbon is attaches. First I'll write as a general formula. What is a general formula? And later I'll write as a complete representation formula. So because we are having little bit doubts. Sir, what is how we can write as a 2-chloropropane? 2-chloropropane means CH3 bond, CH bond, CH3 bond, Cl. Okay. If you write clearly means second carbon atom. So second carbon atom I am taking here. In this one, second carbon atom is attaches with the chlorine. One side it is attaches with the methyl group. Another side it is attaches with the methyl group. Another one is hydrogen. So this is optically inactive. Sir, how you are telling that this one is optically inactive means here the second carbon is attaches with the identical atoms. Whenever it is attaches with the identical atoms, it becomes as optically inactive. Now, this one, how we can write the structure? CH3 bond CH bond Cl bond
CH3.
CH2 CH3 also we can write directly. I am write as a C2H5. Directly I can write as a C2H5. Now, second carbon atom, if you observe clearly, second carbon I am taking as a central atom. Second carbon is attaches with the chlorine, and one side it is attaches with the hydrogen. Another side it is attaches the methyl group, and another side it is attaches with the C2H5. Now, the given compound is containing the chiral center or not? Is the given compound is containing the chiral center or not?
Yes, sir.
Yes, sir.
Okay, so chiral center means chiral carbon means the carbon which is attaches with the four different atoms or group of atoms is called as a chiral. Hence, the first one is optically active. Okay, it's not the optically inactive one. Actually, first one is here optically active compound. So all of you got the answer. Can I give one more structure? Now my question is glycine is optically active or optically inactive? Glycine. Okay, I think so. If you don't know the formula means I'll tell my here. So actually, where will we test this one? Glycine, alanine, valine, and it all means here. So biomolecules chapter is there. In biomolecules chapter, proteins one chapter, one concept it is there. Okay, essential amino acids. Proteins are made up of amino acids. Okay, so in that one, essential amino acids, non-essential amino acids are there. There we are getting here. Now my question is sometimes I had seen somewhere this question here. Is glycine is optically active or optically inactive? Glycine. Glycine. So glycine molecular formula is NH2 bond CH2 bond COOH. So this is the molecular formula of the glycine. Any one of you is glycine is optically active or optically inactive?
Sir, it's inactive because it has 2H group.
Very good. Very good, Aditi. Very good. Exactly correct answer. Okay, so this one is one side amine group it is there, another side carboxylic acid functional group is there. Two hydrogens are directly attached to the carbon. Okay, that means it has a achiral. It's not the chiral. It is a achiral. Okay, if it is achiral means it does not exhibit as a optical activity. Hence, the glycine is optically inactive. Optically inactive. Okay, so sometimes based on the compounds only. Okay, so they're asking some question. So find out the total number of optical isomers. So before that one more I'll give one. So one more question I'll give you here. What is another one means here? Tartaric acid and mesotartaric acid. So do you have any idea about the structure of the tartaric acid? Any one of you?
No, sir.
Tartaric acid. Tartaric acid. So tartaric acid means we can write as a COOH bond H OH. This one we can write as a OH H bond COOH. Okay. In this one, my question is how many chiral centers are there in a given compound? First of all, is tartaric acid is optically active or optically inactive?
Sir, it is optically active.
Very good one. How
Sir,
many chiral centers are there in a given compound?
so there are two.
Two are there. Okay. So I'll give the numbers. Can you tell me the chiral center numbers here? I'll give the numbering. 1, 2, 3, 4. So which are the chiral centers?
2 and 3.
Very good. 2 and 3. So 2 and 3 are here, chiral center. Sir, how you are telling that 2 and 3 are the chiral centers means if you see the second carbon atom is one side it is attached with the OH group, another side it is attached with the COOH, and another side H. Okay, next we have to check it out this one. This whole thing we have to consider it as a one group. This whole thing we have to consider it as a one group. So whenever you consider it as a one group, the carbon is attached with the four different group of atoms. Then only second carbon it becomes as a chiral. Similarly, third one also it becomes as a chiral. Okay. Now one more by question here. What is another question means here? Mesotartaric acid. Mesotartaric acid. Mesotartaric acid. Mesotartaric acid. Is mesotartaric acid is optically active or optically inactive? Okay. Now for this one, I'll write the structure clearly. COOH bond H OH bond H OH bond COOH. Right, sir. This we can call as the mesotartaric acid. So is mesotartaric acid is optically active or optically inactive? Point number 1. Anjan, Samita,
Sir, it's optically active.
Aditi, once you check it out, don't get tense. See the structure clearly.
sir, is it optically inactive?
Sir, only two options, either optically active or optically inactive.
Yeah.
Of course. Okay. Aditi, your answer is correct. Anjan's answer also is correct. Anjan, on which basis you are explaining it is optically inactive? Aditi, you are telling that optically active. How it is optically active? Any reason is there?
Sir, because
We
like
take each
2
carbon
hydrogens.
atom.
One second, one second. Aditi, let's first to complete Aditi.
So like if we take each C atom, that is second and third, it
Okay.
will have a COH group, then the
Very
entire.
good. So that means you are telling that so mesotartaric acid is having two chiral centers. Is that clear?
Yeah.
Okay, right. Anjan, so what's your answer? Anjan, you are giving some answer right now.
Sir, like it's bonded to like another hydrogen like thing of here this line.
No, no. So you're not giving correct explanation, but your answer is correct only. Sir, last time I told that. Sir, if the compound is exists any kind of symmetry, this it becomes as a optically inactive. Is that clear? Aditi, Samhita, Anjan, any kind of symmetry. So actually we have a three types of symmetry. Center of symmetry, axis of symmetry, plane of symmetry. Okay. Now, according to the Anjan, whatever the answer you give correct only. Okay. So generally mesotartaric acid is optically inactive. Generally, mesotartaric acid is optically inactive. Sir, how you are telling that optically inactive means it has a plane of symmetry? If you got like this means here, are you getting two equal halves or not? In this direction. Aditi, are you observing? If you cut exactly, okay, so in middle, if you cut means here, you will get as two equal halves or not? Above one is and above one, below one, both are same or different? Aditi,
The same.
same. So if the compound is exists any kind of symmetry means it becomes as optically inactive na? Okay. Now in this case, mesotartaric acid is generally optically inactive, but it is optically active. Sir, how it is optically active means here because of it has a chiral centers. How many chiral centers are there means it has two chiral center. It exhibits as an optical isomerism due to the presence of the sir rotation. It exhibits as optical isomerism. But half of the part is rotates clockwise direction, half of the part is rotates in anti-clockwise direction. That time net optical isomerism, that net optical activity becomes as a zero. Okay, net optical activity becomes as a zero. Okay, so now you got the clarity, all of you. All of you got this is an exception case. This is the exception case. Sometimes they're asking the questions: is mesotartaric acid is optically active or inactive? Okay, sir. So we can say optically inactive due to the presence of the plane of symmetry. Symmetry is that means it does not exhibit as optical activity, but it is optically active. Why it is optically active means due to the presence of the chiral centers. Sir, how many chiral centers are there? Means it has a two chiral centers. Okay, with respect to the chiral center, it is optically active. Due to the presence of the plane of symmetry, it is here optically inactive. So now got the clarity. Otherwise, I'll write the statement. Exception case, better I'll write a separate mark here. Okay. So due to the presence of plane of symmetry, plane of symmetry becomes optically inactive. Becomes optically inactive. Okay. And what is the second condition here? Due to the presence of due to the presence of due to the presence of chiral center becomes optically active. Becomes optically active. With respect to the chiral centers, it becomes as a optically active. It is an exception case. Clearly, I wrote the statement. Now you got the clarity. Okay. Aditi is left. Now you got the clarity, all of you. Next one. Sir, so we have to calculate if they had given this kind of.
Both optically active and optically inactive, right?
Which one, ma? It is both optically inactive and optically active. So when we can say optically active means with respect to the chiral center. Samita.
Yes,
With,
sir.
with respect to the chiral center, we can say it is optically active. But it is the plane of symmetry, it is that's why it is optically inactive. Now you got the clarity?
Yes, sir.
Okay, right, ma. And here, sir, they're asking to calculate the total number of optical isomers. Total number of optical isomers. Optical isomers. Sir, how we can calculate the total number of optical isomers means we have some formulas, sir. So based on that formulas, we can calculate the total number of optical isomers or not total number of stereo isomers directly we can calculate, sir. So which one we can calculate here? Total number of isomers we can calculate. Okay, total number of stereo isomers we can calculate, sir. Okay, stereo isomers. Sir, how we can calculate the total number of stereo isomers means first. So what is the condition means? First condition, sir. Okay, the first condition. What is the first condition means? If the terminals are not same, the terminals are not same. Okay, to calculate the total number of isomers. Total number of isomers. Total number of isomers is equal to 2 to the power of n is the formula. In this one, n is equal to number of chiral centers. N is equal to number of chiral centers. Number of chiral centers. Okay. Shall we see one example based on this one here? So I'll give one example according to the statement. For example, if I had given COOH and bond H OH bond OH H bond CH3. So this is the compound they had given. So they're asking the total number of isomers. Either the given compound is exhibit as a total number of isomers.
But it has
Huh?
four isomers.
4 isomers. Very good. Okay. So how you are finding out the 4 isomers means because of first we have to find out the number of chiral centers. How many chiral centers are there in a given structure? How many chiral centers are there, ma?
Two.
2. So we have 2 chiral centers. So that means this is the one, second carbon and third carbon. If it is the 2 chiral centers means we can write as a 2 power n is the formula. If 2 power n means, sir, how we are writing as a 2 power n only means terminals are different. So because of one end carboxylic acid group it is there, another side methyl group it is there. If the terminals are not same, so that time we can take as a 2 power n. N is equal to number of chiral centers. In this one, n is equal to 2 means 2 power 2. The total number of isomers is equal to 4. Okay, I'll give one more example. One more example to you. Now let's see. So who will give the answer? Any one of you. Right now. The total number of stereoisomers. Oh, the time up. I'm discussing about the questions. Make it fast. Yeah, Didi.
Is it 8?
Exactly, Aditi. Exactly. Okay. So how many chiral centers are there?
Sir, 3. The second
Very good.
one
Very
and the
good.
fourth one.
Anjan, any doubt is there? How many chiral centers are there, Anjan? Anjan. Samita, do you have any doubt in this one?
So it's at the position of Cl, Br, and Cl, the 3 carbon atoms.
Okay. Okay. So 3. This also we can write in this formation to make it clarity. Okay. How we can write means here CH3. So terminal 1 is CH3 and this I am writing as a H, Cl, and another one is here Br, H, another one is I wrote as a H, Cl, bond C2H5. So terminals are different. We have a 3 chiral centers. Due to the presence of the 3 chiral centers formula, we can apply 2 power n. So 2 power in this one, n value is equal to 3. Then 2 power 3. 2 power 3 value is equal to 8. So total number of optical isomers is equal to 8. So all of you got the clarity? Next condition. So what is the next condition means here? Second condition, case 2. Case 2, second condition. Okay. Condition 2, all right. Condition 2. So what is the condition 2 means here? If the terminals are same, the terminals are same. If the terminals are same, in this one also case 1 it is there. So what is the case 1 means here? Case 1. The case 1 in this one. If it is having even number of chiral centers, okay, if the compound is having, if the compound is having even number of chiral centers, even number of chiral centers. If the even number of chiral centers means, let us see now. Here, the total number of isomers, total number of isomers, Okay, in this one we are considering this as optically as optical isomers and meso compounds also. Okay, for optical isomers, optical isomers. Sir, what is the formula for the optical isomers? Means 2 power n minus 1. Okay, and for meso compounds. So meso compounds, what is the formula? Means 2 power n by 2 minus 1. So to calculate the total number of isomers, total number of isomers is equal to, how we can write this, 2 power n minus 1 plus 2 power n by 2 minus 1. So this is the formula. Okay, and case 2. Okay, so what is the case 2? Case 2. What is meant by the case 2 means here? Case 2. So what is the case 2 means here? In this one, so first we have to take as a, the compound is containing odd number of chiral centers. The compound contains odd number of chiral centers. Odd number of chiral centers. Odd number of chiral centers. Okay. Now, if it is having the odd number of chiral centers means in this one. So total number of optical isomers and our meso compounds. Okay. So number of chiral centers. Here number of optical isomers. Optical isomers is equal to 2 power n minus 1. Okay. And meso compounds. So how many meso compounds will get as means here? 2 power n minus 1 by 2. Hence the total number of isomers is equal to 2 power n minus 1 plus 2 power n minus 1 by 2. So by using these formulas, we are going to calculate the total number of isomers. Clear? Until that? Now based on that one, I'll give one example to you. I think so it's going to be disconnected. I don't know. Tartaric acid, sir. The number of isomers are exhibited by tartaric acid. Any one of you. The total number of isomers are exhibited by the tartaric acid.
So can you scroll up a little to the formula for the case 1?
Case 1, ma? Now you got?
Yeah, sir.
Okay. Case 2 also you can check it out. Both I will give you. The total number of isomers are exhibited by the tartaric acid. I think so it's going to be disconnected. You have class? Anyway, please try these two. If it is disconnected, means no problem.
Sir, could you explain what meso means?
Meso means if the identical atoms are present at same site, means that we can call as a meso.
Okay.
Okay, so meso tartaric acid we wrote. What is the meso means? If the identical atoms are present at same site, means that we can call as a meso. For two conditions, two examples had given. Can you calculate the total number of isomers? Next math class is there. I think so some other class is there.
3.
At what time are you having class?
8:30.
8:30, yeah, time up. So please copy this one and you can solve the questions. In next class, you have to give the answers.
Sir,
All
could
of
you explain how to do
Samhita.
it?
Samhita is giving answer. Samhita, tell me.
Could you explain how to do it, sir?
I have to explain this one.
Okay,
Is the
yeah.
answer 3?
Could you explain one of them?
In this one, n value is equal to 2. In this one, n value is equal to 3. First one is terminals are same, but it has how many chiral centers?
2.
2. So terminals are same. Chiral center is 2 means even number or odd number?
Even number.
Even number means which formula we can use? Case 1 or case 2?
Case 1.
Okay. Second example once you checked out. Terminals are same or different?
Same.
Same. Number of chiral centers?
3.
3. So second formula. N value if you substitute means you will get the answer. In this one, what is the answer you will get means 2 power 2 minus 1 plus 2 power 2 by 2 minus 1. So 2 power 1 plus 2 power 0. 2 power 0 value 1. Total number of isomers is equal to 3. But this one 2 power 3 minus 1 plus 2 power 3 minus 1 by 2. So in this one 2 power 2 plus 2 power 2 my 2 by 2. 2 by 2 means cancel means 1. 2 power 2 value 4. 4 plus 2 6. So this is the value. So this kind of questions are there. What are the assignment I forwarded yesterday? So please try all the questions. You'll get some idea. Okay. So whenever you get the free time, just you try. If you're having any doubts, means just next class we will discuss. Okay.
Yes, sir.
So thanks a lot. Thank you all. Hope so you understood everyone.